Right, friends, let's get started now. So, what I'm going to do here is the approach that we are going to take now is that you have already done things on your own machine, right? That's nice. And you can see my screen, right? You can all see my screen. Okay, fine. So, um, yeah, the point here is that you have already done these things on your machine, right? As per the explanation, you were supposed to create, three major things. One is the model classes itself. Second, you were supposed to create the repositories, and you were also supposed to create the DAO IMPL classes. That's what you were supposed to do. So now the point is that what I'm going to do is I'm going to do the same thing on my machine. You have already done things. See what I am doing vis-a-vis what you have already done, whether that matches or not. If it does not match, then in that case, just write down the points where you have gone wrong. Write down the points that you may have, questions, with respect to, and then you can shoot those questions, and then you can tell me whether you did exactly what I am doing or you did something else. And if you did something else, then what was the reason why you did that something else? You can start discussing your points if it is not in line with whatever I have done. Okay, so that's what we're going to do. So please see this. All right, that makes sense, correct, isn't it? Right? So I'll say package, and what I'm going to do is I'll say counted example dot. I'm not going to, as I said, I am not going to run this application. It is just for the sake of discussion over here. So I'll say com dot example dot. I will give university, okay, or I'll say com dot university, okay, whatever that university is, and then I'll say dot model. This is the package that I have. See this here. I'll go on very quickly. See, the first thing is that I will create model classes because everything is dependent on that. So the first thing that I will create will be the model classes. That's how the flow is supposed to be. The domain modeling also is already done. This is my domain model based on which I will start creating classes. So now what is the name of the class? I'll say course is the name of the class that I have. Okay. I'll just start creating classes. I won't even create properties. I will create properties later. And then I got a class again. The other class, a student is the class, correct? Then another class, I'll say class again. And then this time the name of the class would be, professor, right? This is the name of the class that I have. I'll close all that. And then again, I'll say a class. And this time I will give the name of the class as student schedule. Okay, this is the name of the class that I have. And then again, another class here. I will give the name of the class as course offering. See how simple this is. It's the rapid. Okay, this teacher table and all that was just for the sake of bringing up a point with respect to association class. So we will keep that aside. So 1, 2, 3, 4. You got 6. So 1, 2, 3, 4, 5. I have not created anything with respect to scheduled offering, right? I have not done anything. That about that scheduled offering there. So we will come to that a bit later. Or else let me create that. I'll say scheduled, sorry, hey, I'll say class, and I'll give the name of the class as scheduled offering, So that's how it is. Now, I will say course. What are the properties of course? I'll say, private, int. Always use, the wrapper classes over here. Okay, there is a reason for it. We will discuss that later. As a private int, okay, course ID. Fine, that makes sense. I'll say course ID. I'll say private string. I'll say name of the course. Okay, and then I'll say course offering. Right here, now see this private integer. Now this is the point. If you have not done this, then please make note of this. I'll say course offering ID. That's fine. Okay, but here you see along with I will have private string title and all that stuff and blah blah blah, all the other things. Here course offering is related to course, and I can see that one instance of course offering cannot exist without the course. Why? Because one instance of course offering is related to exactly one course. When I say exactly one course, it cannot exist without the course, right? I will, in order to establish a relationship, see what I'm doing. I'll say private course like this. Getting my point? Private course. So with this, I will be able to, given a course offering, I will be able to get which course that course offering belongs to. I will click right mouse button. I'll say, generate setter getter methods. Here you go. And then I'll just simply say select all, and I'll say generate, and my setter getter methods are generated. You got that? Okay. You know what? That course offering has gone down. Yeah, correct. I'm sorry. Yeah, that's correct, right? This is how it is. This is how it is. And for course also, I will click right mouse button. I'll say source, I'll say generate segregated methods. If your IDE has hotkeys for it, then you must definitely use hotkeys. If it is Windows, definitely this has hotkeys there. Okay, the shortcut keys, sorry. Professor, what kind of properties will I have in the professor? Private integer, I'll say professor ID, okay, and I'll say private string name of the professor, and there can be other fields as well. But I must go back to course offering. Don't you think based on the relationship, each course offering will be related to one object of class professor? I will definitely have here what? Private professor, professor here, like this. Okay, that's how it is. That's how it is. Okay, let me go back and have I'll say, generate segregator method here, and I will have for that one pending professor also. Correct? This is what I have. I have a professor, set professor, and get professor. Scheduled offering, I will come to that later. Student, I will have private, okay, integer, and I'll say student ID, private, I'll say string, name of the student. Well, we will talk about, other properties can be there, that's fine. But in student schedule, okay, student schedule, I will have private, integer, student, okay, schedule, ID, correct? And then I will have private, I'll write string, semester, okay, something like that. Private, I'll say local date, always from Java 1.8 onwards, use local date, and I'll say, creation date, something like this, okay, and then so on. And then I will import that from that, and then generate certificate methods, and I'll say select all, and then I'll say generate. That's it, done. Okay, so I have my model classes in place. Select, this is what I have. What is it that I have? I have my model classes in place. You got that? Now, what about scheduled offering over here? You see, there is a relationship here between course and course offering. Also, we have a relationship here, right? We've got course offering. You can see this course and course offering. And here I do have in course offering course object, I have professor, professor object. Am I right or not? Now, you know what? Don't you think these classes will actually become at the rate entity? Come on, yes or no? If at all the name of the table in the database is not exactly course offering, suppose you say course offering master, you want to, somehow or whatever, for whatever reason you want to have course underscore offering as the name of the table, you can say name is equal to course underscore offering. Or else if you know that the name of the class over here and the name of the table in the database is exactly the same, then in that case you can very well, ignore that giving the name of the table explicitly, and in that case it will automatically do the mapping. Correct? But there is yet another thing, at the rate ID. This is what you're going to do, at the rate ID. Why? Because this is supposed to be the primary key. Similarly, here also course, and I will go to at the here I will say what? At the rate entity, okay, and then here I'll write what? At the rate ID. Correct? That's what it is. See, that's what I'm going to do. Similarly for all the other also. But the point here is now JPA is very smart and very, very powerful. It allows you to establish the relationship between course offering and course right here in this particular thing. When you have got, you can see the set course and get course over here, especially the get course part over here, you can establish a relationship here. You can very well establish a relationship, and you can establish a relationship in such a way that whenever you retrieve course offering, I repeat, whenever you retrieve course offering, it will automatically read the corresponding table in the database for course, because course belongs to what? Course is the object of what type? Course. And this course is also an entity. That means there is actually a mapping and, a table mapped to this course. It will automatically fire a select statement to what? To the course, okay, and it will fire the course ID. So I will have to have a string, and I'll say integer course ID. Okay, that's how it is. Or wait a minute, I don't need this. I'm so sorry, I don't need this. The relationship that I will be establishing over here, sorry, the get course, the relationship that I will establish here will have that mapping foreign key relationship. I repeat, here you will have that mapping foreign key relationship, which will automatically tell your JPA that you have to fire a select statement in course and get the corresponding value. You're getting my point? The primary key of it. and it will fire the course object, and whatever the course object is created, it will set that course object here for that course. So that relationship can very well be established over here. Similarly, between student offering, scheduled student offering, and all of that stuff, with the with professor also, right? You've got professor here. So I will go to professor. I'll say at the rate entity, and then I'll say at the rate ID over here, and you will be able to establish relationships from course offering to professor also. Where will you establish that relationship? Get professor. Here on top, you will have annotations used in order to establish relationship. You got that? Okay, but that relationship, I will save it for another day. We will discuss that later. As such, if you ask me, I am not a big fan of it. I'm not a big fan of relationship between JPA, especially when it comes to, because what happens is that finally it ends up using a join, and join is always the reason for performance related issues. I mean, performance will definitely come down of your database operations if there is a join there. Correct. So joins, I'm not a big fan of joins at all. So what I do usually is that I end up creating for each and every model. I'm not saying that's exactly what you must do every point in time. In some cases, in some application where you know that the database table will not have a huge amount of data in millions, then in that case, you may want to go ahead and establish relationship. Join will not be really that expensive in terms of performance. Okay, but in order to talk about the relationship and how you establish relationship, it's a plain simple matter of putting the annotation over here. I repeat, it is a matter of annotation. But as I said, I want to save it for another day. But still, I would like to show it to you in one of my real life application. Just give you a glimpse of how exactly it looks like. Okay, so let me give you that glimpse of how that relationship actually looks like. Okay, it's starting up. That's another application. Okay, okay. Here you go. Here you go. Here you go. Okay, 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 fine. Okay, I will pick up the class called user. Okay, and I have a model class user here because user is related to roles. Am I right? User is related to roles. Okay, you can see this get roles over here. Can you see there is an annotation? See the kind of annotation that I have over here? Correct? You can see this. Ram, you can see this annotation, Ram? Right? Okay, so you see this, I say it's many to many because one user can have many roles and one role might have been selected for many users. It's a many to many. So there are options over here. I can say many to many. I can say one to many. Okay, you can see this one to many is the option available. I've got many to many option available here. And I say join table. You know what is this join table? This join table is actually nothing but your association class. This, because you keep the association. This is the reason why it is called association class. And see the JPA, it says it calls it a join table. Why? Because these two classes, this class and this class, is joined by this particular class. So it says what is the join table? For us the join table is user underscore role, and then on which columns the join is happening? It's happening on the user ID, and inverse join columns, or the other way around, is the role ID. As I said, we will save this for another day. Right, we will discuss in detail later on. You got that? But then this is how you establish the relationship. And I will go to roles, and there is a many to many relationship, right? So I'll go to role, and in role you will see get users. You can see this many to many mapped by roles. You getting my point? So you know what, given a role, I can get all the users that are there of that role, and given a user object, I will get all the roles of that user by just simply using this annotation. You got that? And I don't need to actually have any class in my application with user underscore role as the entity mapped to it. I repeat, with this kind of relationship established, I do not need a class, a model class in my application, which will represent that association class or that join table. I don't need to have an entity there unless it has got some additional information over and above just the join. Like in case of our example, in case of this teacher and all, there is an additional information called time. In such a case, I will have an entity called timetable so that I can get time into that, right? In other words, you can very well have relationships, used here with JPA. I won't save anything here. I say file, I say switch workspace, and I go back to our workspace of which we were working. So point here is that I will have model classes first created. On those model classes, I will have my at the rate entity specified. Okay, see here, I've got model classes created. You got that? And all of those model classes, professor stuff and all, I will have entity and all. I will have student, and I must mark this also with entity. Okay, okay, entity. Okay, and here I will say at the rate ID. Sorry, at the rate ID. Okay, that's how it is. And then again, student schedule, I will have that, right? At the rate, I will say entity, and then here I'll write at the rate ID. So this, my JPA now understands this, that this is an object. Right? I mean, this is the class which is supposed to map to the table in the database. So this is my model. So I am done with my model classes. You got that? And then next is what I asked you all to create repositories. So I will now create a repository. For example, I'll create an interface here. And the name of that interface will be course repository. Okay. Right, course repository. I must mark it as what? Repository. Got it? And here, tell me what will this extends from? It will extend from JPA repository. Tell me what will be the class over here. It's a generic type. What class? Course, because I'm creating the repository for course. And what will be ID? This is actually the data type of ID. So I will go to my custom, my course. And what is the data type of this course ID? Integer. So I will have this integer over here, like this specified. Correct? That's it. Done. That's it, done. Course offering, repository. Sorry, not course offering, course repository. Then very quickly, I will go to my course offering also. So this is the class that I have. I will create another. Let me do one thing. I created course repository. Let me say package again. And then I'll say model dot repository, or I'll just say university dot repository. Okay, and then I will just move my repository here so that I can show you all the repositories that got created, that we created. Okay, here you are. Again, another interface. Okay, see, it doesn't make a difference even if you say a class. Okay, and I give the name as course offering repository. I can always go back and change it over here to interface, not a big deal. Okay, here I'll say now what? Repository again. Again, this will extends from what? Right? JPA repository. Here I will have course offering, and what will be the data type? Usually we keep data type as integer, either integer or long. I need to import it because it is in a different package. Here you are. That's it. I will leave it as it is. Similarly, I will go on creating a repository for professor, for schedule offering student, and so on. Then what I'm doing here is in the repository itself, I will create a class, and in that class, I will say course DAO. I will change this to, I'm sorry, I should have created this as an interface, right? And then I create a class over here. I'll say give the name of the class as course DAOIMPL. And what is this course DAOIMPL supposed to implement? Come on, course DAO. This is the interface, right? Now, this implementation class is supposed to be marked as what? Component, or else you will, in this component, if you don't mark it as a component, this object of this class will not be created by Spring Container. If it is not created by Spring Container, it will not be able to auto wire the repository. Which repository? Tell me in this course DA. Oh, so sorry. I'm so sorry. Course repository, right? Course repository, and I say course repo, right? That's how it is. Now I will have all the functions over here. I'll say public, I'll write course, I'll write get course by ID, integer course ID, and then what will I do? Tell me. Sorry, spelling of course is wrong. Okay, that's the spelling of course, right? Okay, I did not import it. Yeah, sorry, yeah, I missed that. Okay, then I'll say what? I'll say return. I will write course repo dot. I'll say what? Find by ID, and I will pass that course ID as parameter here. Simple, as simple as this. Okay, why is that giving me an error? Why is that giving me an error? Because it actually returns an optional. Okay, because this actually returns an optional. Now I take this up, I import this, but why is this still going to give me an error? Because okay, it's not giving me an error because I did not declare this function here at all. You must declare the function here. So I will just copy this up till here. I click here, and then I put it over here and add semicolon. So see, course DAO, this is the function that is declared, and course DAO IMPL, this was the implementation of that. Right now, wait a minute. You always from DOIMPL you have to return back optional only. Yeah? If it is one object and if it is finder method like this, don't get it over here and return back. Just say optional only and return back the optional. Now, one of the main reasons of doing this exercise was as follows. You see, I have something called, tell me one thing. Look at this entire thing over here. Look at this diagram here and tell me. What I'm going to do is, I will just close this. I'll again go back to my Safari. I will go back to draw.io and I will reopen that diagram. Okay, I'll say open existing diagram, and I have this. Okay, see, this diagram is with us, right? We have this diagram with us. Now, tell me, now this is extremely important discussion, friends. You've got to pay very careful attention here. Extremely important discussion. You see, between course and course offering, what is it? Do you think it is association or a composition? What do you think? That means if you have course offering getting deleted, you will delete all the corresponding courses. Is that so? Okay, sorry, the other way. When you delete a course, you will get all the course offerings of that course also deleted. Ram, will that make sense? Correct, that's correct. But suppose it is already created. There is Java course and there are 5 course offerings already created. Then do you think the business will agree to this point that, okay, I will allow you to delete a course which already has course offering and I will automatically delete all of those course offerings also. Will that make sense? Correct, right. So in this case, there is an association, not composition. This is not common. This is not a whole part relationship. It does not make sense to say course contains course offering. It makes sense to say course is related to course offering or vice versa. I can say course offering is related to course, but it does not make sense to say that course contains course offering. It doesn't make sense. Got that? But now, similar is the case with professor and course offering. You cannot say that, okay, let me delete the professor, allow me to delete the professor and all the course offerings that the professor had, I will go ahead and delete it. No, it doesn't make sense. Business will say, no, 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 no. Do not allow the deletion of professor. Here also in this case, this is do not allow the deletion of course if it has any related course offerings. Do not allow. That will be the constraint that you will be setting up if at all you move on, whenever you move on to database design. Correct. So, where in this entire domain model, where do you see there is a relationship wherein if you destroy the object of a class, all the other corresponding child objects will also be destroyed? Where do you see that? You see, it is between. Yes, yes. Student schedule and schedule offering. Here you will have a relationship like this. Here you will have a relationship like this. Yes, this is what it is. And you know what? You will have this diamond towards the end of this. Okay. You will have a diamond towards the end of the hole, and you will have, you know, the other end will be over here. What does this mean? Student schedule is made up of schedule offerings. What does this mean? Student schedule, when an object of this class is created, the corresponding schedule offering will be created as well. All of those offerings will also be created. It's like, here in this case, if at all a teacher is deleted, then in that case, all the corresponding timetable will also, for that teacher, will also be deleted. Doesn't make sense at all. Okay. So similarly, here is the case, and there is a composition relationship. Point here is that whenever you have a composition relationship like this, do not create two DAO classes. That is the reason why this discussion was important. I repeat, whenever you have a composite relationship, please do not create DAO classes. So two DAO classes. Create only one, calling it schedule, student schedule, and handle both of these repositories. You can access the repositories from one DAO. You can very well handle the repositories of two, right? So that's not a problem at all. But I will not keep on creating DAO classes for each one of the repositories. I can very well have a logical grouping. I say, okay, these set of domain classes, they exactly go together. They are very closely related. There is a very strong structural relationship here. There is a composite relationship, and hence I will not end up creating two DAO classes. In such a case, what I'm going to do here is, now let me demonstrate what I'm talking about. So you see, scheduled offering is what we already have. I'll say it is an entity, definitely yes, scheduled offering. Okay, I'll say private, and I will say integer, and I will say student, yes, schedule ID. Okay, I'm also not at all a fan of composite primary keys, huh? Not at all. Finally, I will have a one running serial number over here as the primary key that eases my select statements and my where clauses and stuff. So I will say integer, but that is again for another day. So integer, I will say course offering ID. Okay, and then I may have some additional, information over here if I needed it. I have student schedule. This is again marked anyways. Course offering is anyways marked as entity, right? So how many DAO IMPLs will I have over here? I'll say class. Sorry, I will have repositories for sure, right? I will have repositories for sure. So I'll say interface over here, and that interface will be for what? I'll say student. I'll say schedule. I'll say repository, okay? And then I will mark it as a repository over here. I'll say extends JPA repository, and then I will say student schedule repository, sorry, student, I'll say schedule, okay, student schedule. Of course, there also we have the data type of the primary key as integer. And then course offering repository I have already created, sorry, I have not created for scheduled offering, right? So I will create control N. I'll say interface. I'll say scheduled offering repository. I will say again, this is at the rate repository. I know guys, y'all are hungry. It's already 127. Just give me a few more minutes. I'll say extends JPA repository. Here I'll say schedule. Building applications is nothing cakewalk, see, like this. Integer, of course, when it comes to real life application, there is a lot of business logic where you will be spending a lot of time. Business logic, that too, if your concepts are crystal clear, if you have step by step implementation of your entire application with proper planning and with proper analysis and design, it's just a cakewalk. It's just a cakewalk. If you do not know what you will be writing next, it's a chaos. So you must know what code you are supposed to write. You're not supposed to think while writing code. First you think and then you write code. That's how it is. Okay. So scheduled offering it. Okay, you must also think while writing code. Also, that's also important. So I have my, major thing that I want to talk about is student schedule and student schedule, the scheduled offering. This has a composite relationship as I talked about. Okay. So how many DO IMPLs will I create? I'll say class. I'll say student schedule, okay, as a student schedule, DAOIMPL, okay, here you are with a class. I will of course have control N, again I'll say an interface. I'll do this, but I will remove IMPL from here. Okay, so I have an interface here, you got this, and there is a class here which wherein I'll say implements what? Student schedule DAO. Okay, this is what I have. Now, point here is this. I will handle everything with respect to student schedule as well as student schedule offering from here only. I will have two auto wires over here. One is auto wire to student schedule repository. Okay, I'll say schedule. Okay, I can give some meaningful name, and I will have yet another at the rate auto wired. Here I will say student, sorry, schedule offering repository. I'll say offering repo. Now with this, I will be able to access both the tables in the database. I will be able to access both the tables in the database. And in such a case, whatever functions I have, I will actually use those functions. And within those functions, I can access both of these repositories. That means two different tables. And then whatever data I get, I can put it into. Let me finalize this by saying that I will have yet another package here, a package. I will call that package as VO package. VO stands for value object. I'll say a class and I will give the name of the class as, you know, scheduled of, sorry, a student schedule. Okay. VO, I'll say value object, and I will create all the properties that are already there in the student schedule. Okay. This, all the properties over here. And at the same point of time, I will over and above that have, I will have private schedule. Okay, offering, I'll say offerings. Okay, this is what I'm going to have. But here, friends, please see this. I will have list. Why list? Because there is multiple, yeah, there are multiple offerings. Four offerings he can select, yes or no? I will have scheduled offerings of a list like this. Now once I have this kind of a value object here, I can go back here. Okay, in fact, you know what, I can also have something like this. I'll say private, and I'll say student schedule this entity class, and I'll say schedule, right? I have this, see this, and the list of scheduled offerings is also over here. You're getting this point? And then I'll click right mouse button. I'll say run as, sorry, source, setter getter methods here. I'll say select all. Okay, generate. Now see, let me make a point over here. It is quite possible that you may decide not to create this value object if you know that the student schedule itself has what? You remember that? Private, I'll say schedule offerings. If you already have the schedule offerings, but wouldn't that be a list? Correct? It will be a list, right? Offerings. Here you are java.detail.list. And if you have something like this, I can click right mouse button, source, generate setter getter methods, select all. You remember the relationships that we had talked about? So I can always have get offerings over here and I can have a relationship established here. If this is the case, then you may decide not to create a value object like this with, both of these things, whatever, I mean, it depends on different kind of, the decision that you would take. All in all, you will have one single DOI MPL. I will go by the value object approach. I'm more, comfortable with that. I'll say public. What is it that I'm going to return back? Schedule, sorry, student schedule value object is what I want to return back. Or else, wait a minute. Here, I better return back the student schedule itself. And I'll say get student schedule. Okay. And what is it that I'm going to use? Schedule repo. Similarly, if I want to get all the offerings of that particular, so I'll just say return null here. I know it is becoming a bit of a, but then no problem. It's a good shot. I'll say schedule offering. It's a list of schedule offering. Here it will definitely be what? In, I'll say integer of student schedule ID. Okay, here again I'll say get student schedule, or I'll write get schedule offerings, and here also I will have integer. I'll say student schedule ID. Okay, here you are, correct? So this is what it is, right? And I'll say Control Shift O, and that's Java data list. You will write code over here. Which repo do you think you're going to use over here? Which repo? Somebody, this one, offering repo. This is what you're going to use, right? Offering report dot. You will say find by. We will discuss about finder methods in more detail later. That is how it is. In short, you are using one single DOI MPL because these two are very much related together. You got that? And you will have functions. And that, the value object that I created, we will construct this value object in the service class. I repeat, we will create, we will do, we will do the implementation. We will call this function, we will call this function. And in the implementation of the service class, we will, set the offerings into the schedule over there in the service class and we will return it back. You got it? So what will happen in that case? If any student wants to see his schedule, we will fire an API. API will make a call to the service. Service will in turn make these two calls and then get the data, put it together into a value object, and then return it back to the API. That's how it is. So this completes our. Now tell me, friends, if you have any questions, any doubts you have, if you did something really very different, than what I have done over here, or if you want anything for anything that needs. I mean, if you feel that I must explain any one of these points again, please feel free to tell me. I'll take a pause here. Yeah. Yes, Ram. Yes, Ram. Oh no. Good you did that because that's not how you're supposed to do it. Yeah. Mm. You got. So you. That is not the case. See, only and only when there is a composition relationship like this. Okay. And another example I will give you. See, many a times we have one customer and one customer has got many addresses. Okay. So you will have two tables over here. I mean, you have two classes when it comes to domain driven. You will have two classes. You will have one as the customer class. Okay. And the other would be a customer address class. This is something very common, right? Right? I'll say customer address. Now, this is so very related. There is a composition relationship here. There is definitely a composition relationship like this. You see, and the diamond will be towards the end of the customer, and this will be towards like this. What does this mean? When you destroy the customer, all the customer addresses will also be destroyed. Correct? If this is the kind of relationship, you will have one DAO class for customer and customer address. Right? Otherwise, if you go by relationship, there is no table in the database that sits in isolation. Right, so you will always have, you will end up creating one DAO for everything. So whenever there is an association relationship between the two domain classes, which is mapped in turn respective to their respective tables, you will not create, one single DAO. But if there is a relationship like this, you will end up creating one DAO. Okay, good learning, good learning. Yeah, Ajmal had a question. Yes, Ajmal. Same question? Correct. So you always keep on creating different DAO classes, because why? Because, say for example, something like course and course DAO IMPL, you will have n number of requirements over here, which is very specific. For example, you may want to retrieve all the courses uh, you know, where the duration is more than 5 days, for example. Or perhaps you would want to retrieve all the course offerings, from the DAO IMPL of course offering where all the course offerings starts after a particular date, correct? So lot of requirements with respect to access to the databases will be different from one repository to the other repository. In other words, one table to the other table. You will not club everything into one DAO IMPL unless there is a relationship like this, correct? So the best example, Ram, would be for you. We have got something like this, Ram. See, you have a shipment booking, okay, and then you have a relationship with shipment booking containers. Am I right? Right. These containers will have no value without the shipment booking. There is definitely a composition relationship. If you destroy a particular booking, you will definitely destroy all the booking containers that were recorded there. Correct. So don't create two DAO IMPLs. Create one single DAO IMPL in which you will manage the flow. Right? You will access both the repositories. And I hope you all created one repository for one class, right? That is for sure, right? That's how you do. Super, super, super. Very good. Very nice. Anything, any other question? Any doubts, any questions? Anything else from your side, Ram? Okay. Okay. Ajmal, anything else? Tufail, any questions from your side, Tufail? You're there? Okay, good, super. Now, so we will stop this here. We will take a lunch break. Okay, I can see a smile on Ajmal's face. He is pretty hungry. So we will take a lunch break here. But today, let's continue. I will talk about one. Now after lunch break when we connect. We will talk only and only about repositories because there is a lot in repositories. For example, let's take an example of course offering repository, right? There are a lot of things over here that we can do. As I said, there are a lot of functions which are automatically available. Like, give me an example of automatic functions that are available. Yes, find by ID, find all, correct. So those are the functions that are available. We will see few more functions if they are there. But other than that, there are other functions also. We will explore them in repository because this is the heart and soul. That's how you will be getting the data from the database, right? And then we will talk about the custom functions that you can write here. We will talk about the custom queries that you can write over here. Okay. We will talk about one is SQL, the other is JPQL, right? Java consistency, yeah, QL. We will talk about that also. And then we will also talk about the entity manager using which you will be able to fire whatever query you want under the sun. Again, it can be a native query, it can be a JPL query. We are going to talk about how to access the database all in all today. Okay? Repository. So how much time do you want for the lunch break? It's 1:40. So shall we resume at 2:40 or 3? 3 o'clock? 3 o'clock is good? Okay, fine. Come on. Let's continue. Okay, at 3 o'clock. Let's resume at 3 o'clock. Thank you so much. Bye bye.